briefly talked about this on computer science, and you mentioned computer science is increasing the level of abstraction. So every 5-6 years, the productivity for the developer doubles, and Moore's law has doubled the compute in 12-18 months. Obviously, it is happening faster with GPUs now, one would argue. So what do you believe are the most interesting opportunities with keeping that premise in the future that India could really take advantage of?
Right. So I think not computer science or maybe computing paradigm, computational paradigm. It rests on two fundamental principles. It was very complex, but you can distill it to two. One is increasing the level of abstraction, and the second one is called late binding. You bind something as late as possible, which is like, again, a cricketing metaphor. You're playing on an English wicket, damp English wicket. You don't cut across and go across the line, right? You wait and watch the ball to the last. Binding is something like that. Okay. So, binding is, you're committing certain decisions very early on. You should try and commit the decisions as late as possible.
Okay.
Because then you get more flexibility. It's like you're getting more choices. So hardwired architectures is the least form of binding, in the sense that I'm committing or baking an algorithm into the chip. I can't change it once it's taped out, right? A programmable thing is one step better than that, where, I'm able to change it very late. One step further is, the concept of hypervisors. The whole cloud paradigm rests on the concept of late binding.
Yeah.
You got an hypervisor. You don't bind an operating system to a machine. You have an hypervisor in between that you can run multiple operating systems. Then you have containers that can actually run. What helps here? How does it help? You can use compute resources far more efficiently. That's why large farms of servers in the whole thing in the data center is all about how do I reduce power? How do I reduce the amount of equipment? How do I reduce the amount of resources I use to build out a particular workload? That workload could be a GPU workload or an AI workload, or
could be anything.
Whatever. It could be anything. Those two principles are really fundamental from a semiconductor perspective. So what does that translate to? It translates to building better custom programmable architectures. Like, for example, in Sankhya, we set out to build programmable custom architectures that bind late for modems. This is a very difficult problem to solve. You could look at other workloads to do that. You could build frameworks, software frameworks, which allow you to bind late, which means today, one of the reasons why it was difficult to displace Intel and now difficult to displace NVIDIA is because of the amount of software that's being already built on it, right?
CUDA being an example.
I mean, it's more a software company than a hardware company. CUDA is the real mode that comes in.
Agree.
Yeah.